Hello everyone. Today we are going to learn 4.2 cooling and mixing. But we did a mixing last course, not last course, last section 4.1, right? So I'm gonna do just one question about the cooling. All right? Okay, so here we have Newton's law of coolings. Okay, so we are going to talk about temperature here. So temperature, so we are using just the first letter T, so uppercase, so T over T. So this is small t in terms of time, right? And time T is a medium with temperature, and then we denote medium is T sub m over T, right? Can you see that? So just regular equation, we have temperature T over T with the time T, right? And medium with the temperature T sub m over T. So what is a medium? Yeah. So I highlighted medium here, right? So let me explain to you later after this formula, right? So Newton's law of cooling, right? And they say that medium with the temperature, the rate of change is missing of t at time t. Then proportionally to we have like that. Yeah. And then we have a formula T prime, which is dt over dt minus k T minus T sub n. So what is T? T is temperature, lowercase t is time, uppercase is T temperature, right? And T sub n, which is ambient temperature of object surroundings. Yeah. Okay, let me read this one more. This one again. Then I'm gonna talk about the medium. What medium means. So since temperature of object must decrease, so the temperature must be greater than that medium with the temperature, right? Or increase if the medium with the temperature, right? So either way, right? And then we call the K, so we are using any letter, any variable. K is, but in that case it's K, right? So K is the temperature decay constant of the medium. Yeah. Okay, so what is a medium? So medium means surrounding. Yeah. Okay, surrounding by what? Right? So look, hot coffee. So example of medium here. So hot coffee is air in the room is the medium. So in that case, air. Yeah, make sense? Oop, oop, sorry. Okay, second one, example, a metal rod in water. Yeah, people do that, right? So in the like a local company, they do that a long time ago too, right? So water is the medium, right? Make sense? And food in an oven. So hot air is the medium. Make sense? On ice cube, number 4, oops. On ice cube in your hand, so your hand plus air is medium, is the medium. Make sense? Okay, so constant of the medium, which is K, right? So this means how quickly the surrounding can heat or cool the object. So we understand what is medium means, right? Okay, so let us do one question for this section, right? By using Newton's cooling, yeah? Okay, so suppose a cup of coffee begins 170 degree. It's a Fahrenheit, right? And after sitting in room temperature of 66 degree for 30 minutes coffee, right? And coffee reaches 164 degrees. How long will it take before the coffee reach 140 degree, right? Okay, let's analyze. Yeah. So coffee begins 170 degree means initial value, right? So T of 0 when T equal to 0, time is 0, right? Means T equal to 0. Yeah. Time is 0. Then the temperature is 170 degree Fahrenheit, right? Okay. Sitting in room temperature 66 degrees. So we say that this is a ambient surrounding, right? So we are using T sub M. That's the medium, right? Okay. Now, for 30 minutes, the coffee reaches 164 degrees, right? That means when T equal to 13, means T equal to 13. In that case, a minute, right? Yeah. Then the T over 13 equal to 164 degree. Make sense? Okay, now, how long will it take before the coffee reaches 149 degree, right? So T of lowercase t time t equal to 140, then we need to solve for t, right? Time t, right? Okay, so the answer must be round to two decimal places. Okay, here is the formula, right? So I brought here. Let's do that. Okay, so we knew ambient surrounding, right? Room temperature, which is 66, right? So let's simplify. I mean, the substitute. Okay, so also, okay, let us do that first. Yeah, minus KT minus 66. Yeah. Okay, then what? We multiply by the T both sides. Okay, what we are doing right now. So okay, the goal is, let me write down. Goal is we want to find d over d over dt, t over t, right? And then um, finding t over t, then solve for t, right? The time t. Yeah. Okay, this is our goal. Yeah. All right. So we have dt equal to negative k t minus 66 dt, right? All right. So all we have to do. So we want to make t variable other side because t is here, dt, right? And then rest we make stay here, right? Okay, let us do that. So divide by t minus 66. Okay, so there will be 1 over t minus 66 dt equal to negative k dt, right? All right. Now what? Yes, we need the integral, right? So let us integral. So we have dt over t minus 66 equal to negative k dt. All right. So what do you get? Left side. Left side we get natural log t minus 66, right? Because think 1 over x. Yeah. Okay, what about the right side? Right side, just t, right? Because k is constant, right? So negative kt plus c, right? All right. Okay, then we want to solve for t so that we can make the equation t of t, right? All right, solve for t. Okay, let us do one by one. So take the e both sides. So that will be natural log t minus 60 equal to negative kt plus c. Yeah. All right. Then the left side will be t minus 60. Oh, made a mistake. 66, not the 60, 66. I'm checking on you. All right. So we have e to the negative kt plus c. Okay, now we knew that this will be, let me rewrite. So we know that the right side will be e to the negative kt and e to the c power, right? Okay. Now there will be what? Uh, Almost done, right? So we have a t there, and then we want to solve for t, so plus a 66 both sides. So we get that, right? So t over t equal to 66 plus e to the negative kt e to the c power, right? Okay, so we call this a solution, uh, general solution, right? So this is a general solution. Okay, now we need to find the such c, so we can find the particular solution, right? All right, so let's make this is as a C, yeah? Let's say equal to C. So because it's more easily to carry every steps, and we get the same answer. All right? Okay. Then let's say using what we have initial value. The in the beginning, right? So t of 0 equal to 170. So t of 0 equal to 170. T of 0 use 170. Yeah. Okay. So t of 0 equal to 170 equal to 66 plus e to the negative k. And t equal to 0, right? So that is a t, right? So t equal to 0. I should use a different color. Yeah. So t and 0. And that's a C. Yeah. And solve for C. Okay. So then we have 170 equal to 66 plus C. Then C will be what? 170 minus 66, which is 104. Yeah. Good. 104. All right. Then we have T over T equal to 66 plus e to the negative kt and 104, right? So let me using 104 in front here. Yeah. Okay. Now, uh, we still have unknown variable, right? So we have to have t over t, and we have to have only unknown t itself so that we can find the t, right? Time t, right? So how do you find negative k? Is k, right? How do you find the k, right? So we have another information in the case. So they say that for 13 minutes, the coffee reaches 164 degrees. So let's using that, okay? Then finding K, then we substitute K, then only T is unknown variable in the case. Make sense? Okay, let us do that. Hmm. So for finding K, to find K. Use T over 13 equal to, how much was it? 164? 164. Yeah, this one. 164. Okay, so T of 13 equal to 164 equal to 66 plus 104 e to the negative k. This means t equal to 13, so it will be 13 for the t, right? And then solve for k. Okay, so we subtract. So 164 minus 66, which is 98, equal to 104, e to the negative 13k, right? And divide by 104, both sides. So we keep that, right? Because it's not the nice number. E to the negative 13k. And how do you solve for k, right? So take the ln both sides. Natural log. So we have 98 over 104 equal to e to the negative 13k. Okay, then that will be natural log 98 over 104 equal to negative 13k, right? And divide by 13 both sides. So can you please calculate the whole thing? So K will be 0.00457. Yeah? Okay, now we have the solution, particular solution, so equal to 66 plus, yeah, 66 plus e to the negative k. So k is 0.00457 t plus, oh, missing the 104, right? So 104. Make sense? So almost done. Okay, now we need to find how long, right? So to find the time t, okay, use t over t equal to, we want to know how long will it take 149 degree, right? So 149, 149. Okay, so we have t of t equal to 149, which is equal to 66 plus 104 e to the negative 0.00457 t. Now solve for t, right? Okay, 149 minus 66 equal to 104 e to the negative 0.00457 t. What do you get? 83. So 83 equal to 104 e to the negative 0.00457 t. And divide by 104 both sides. So we have 83 over 104 equal to e to the negative 0.00457 t. How do we solve for t? Take the natural log of both sides. Ooh, I need one more pages. So we have 80, 83 over 104 equal to e to the negative 1.00457 t. Okay, so natural log 83 over 104 equal to negative 0.00457 t. Whew, the t is there now, right? Okay, now just divide, right? That's it. Negative 0.00457 both sides. Can you please calculate? All right, so t is 49.34. It's a minute because in the beginning, the statement said that minute, right? So we follow their units. If they don't say anything, yeah, 13 minutes. So we follow that. So if 164. Yeah, so 13 minutes, then the coffee degree 164 degree, right? 149 degree, then we need wait 49.34 minutes. Yeah. So there will be 49.34 minutes will be times what? So there will be 49 minutes 22nd because 0.34 times 60 second, right? 20.4. So we don't want just a 4. So drop. So 49 minutes, 20 seconds. Make sense? Okay. So any question? Thank you for watching. I will see you in the next video. Bye. No, 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 no. Hold on one second. Hold on one second. I have a summary about that, right? So how do we find, right? So sorry. So let me bring this one. So we have, so basically how long, right? In the case, so we need to find, we call the solution in differential equation, right? So we call the regular equation, we called general solution, right? So find the solution, T over T, and then we find particular solution, right? So that means particular solution. And then we need to find such a K constant, right? Then find the time T in that case, right? Okay, thank you, bye.